When you write a set of numbers, when they give you a list of them, you're just showing what numbers are present in that set. You don't have to show 0 twice in it because 0 is a member of it, so you're showing it one time that it has it in it. Okay. So we put them in order for me, just so when we grade them, hopefully they'll be in order and it'll make it a little bit easier when you're asked to put it in set notation. I feel like we skipped one. We did.
We did.
So represent this one as set K. So we put K equals, and then we put them in ascending order. We have 0, 1, 2, 4, 5, 7, and we close it. Okay, that's set. That's a set. It's a collection of points. Okay, a set in tennis. Now let's go volleyball. You know what a set in volleyball is, don't you? What is it? Isn't it?
Little tiny triangle with your finger.
No, not the.
Superman push-up.
Okay, match and
Set.
set. A match is each one of the individual games, and a set is the collection of the games combined, or the matches combined. A set is a collection of the data. Okay, now let's go on to this. All right, we have these symbols here. I'm given this information. Set A, B, and C have these elements. Elements are members or parts of. Are the following true or false? What this symbol means, it's an E looking type of thing. And that's, think of element. E is element. Is it a member of? So A is asking this. Or saying 5 is an element of A. Is that true or false? Is it a member of A?
True.
That's true. It shows up in A, so it's an element of. It's a part of. On B, 4 is an element of C.
No.
Is 4 in C? No, so that's false. Now when we put the line through it, Ghostbusters has a slash through it, that means no goes.
Not equal.
So it's saying 5 is not an element of B. 5 is not in B. Is that true?
Yes.
That's a true statement. So that little sideways E just means element, member, part of. Yes, Ethan?
Aren't E's always sideways?
Huh?
Aren't E's always
I'm sorry.
sideways?
Curve. I'm going to say it differently. The curved E. The strange looking E. You're right, I guess. Example 56.4. We need to go to the book. Given the sets L, M, and N, are the following statements true or false? On A, 6 is an element of L. Austin, true or false? Look in your set L above there. Is 6 in the set L on page 229? Halfway down, 56.4. 56.4 is L an element of 6, or is 6 an element of L? Does it show up in L? So is this statement true then that 6 is an element of L? No, so that is a false statement. B, Morgan Michael, 0 is an element of N. Is that true or false?
0 is an element of N.
That is true.
Thank you, Morgan.
Oh, I just asked. Good job,
Sorry, I'm on the wrong page.
Page 229.
You do that in the other class.
Oh, I don't. Yeah, you do. Honestly,
I
probably
used to
not
do it.
everybody.
They made their point one day in geometry as a sophomore because people start blurt stuff out all the time. And so every time I started talking, 3 or 4 of the guys in the room started blah, blah. I finally got the point. Oh, I'm being rude and interrupting every time they start to say something. Yes, ma'am. So is 0 an element of N? Is that true or false?
True.
That is true. 0 is a member of that. So good on that. All right, moving on. Okay, graph this equation. Remember, it gives us a line. What we've had so far when we're graphing is we've had y equals something. It's already been solved for us. Now we're combining our practice where we've been told to solve this equation in terms of y. That's what we have to do here to get it in the form to be able to solve this or graph it. So we need to get 2y by itself, so I need to subtract 3x from both sides. So I'm going to rewrite this as 2y equals negative 3x plus 4, just because we're used to, or you need to get used to seeing that term with x first to the right of the equal sign. Then we divide by 2 on each part. So your new equation then for this problem is that y equals negative 3 over 2x plus 2. Then we can take values for x, plug them in, and I'm going to use x as 0, 2, and negative 2, and I'm using 2 because the denominator is 2. Plug in 0, negative 3 halves times 0 plus 2 is 2. The arithmetic on that shouldn't be very hard. If we plug in positive 2, I'll come up here for that. I'm going to write that 2 as a fraction by putting it over 1. The 2's eliminate, so that's negative 3 plus 2, negative 1. And then when I plug in the negative 2, negative 3 halves times negative 2 over 1 plus 2. The 2's eliminate. Negative 3 times 1 is, or negative 1 is a positive 3. 3 plus 2 is 5. And that's just arithmetic. You just might have to take a little longer to do that than I did, but that's okay. Then plot these ordered pairs. 0, 2. 2, negative 1. Negative 2, 5. And hopefully those line up to give you a line. And it sort of looks like it. Okay. What?
2 over.
Yes, and I went 1 over. Is there a problem with that? 2, 1. How about that? 2, negative 1. Speak quicker. Don't be talking to everybody else about it being a problem. Save me. Huh?
Can we do another one?
I'm sure we can.
We should do the one in the book, problem 16.
Okay, this one has y minus x equals 0. So we solve for y. This one's easy enough that y equals x. So when we plug in for x, whatever we plug in for x, that's what y is going to be. And then you plot those. No big deal on that.
But it doesn't gotta equal 0?
No, the sum of them, not the sum, the difference of them would have to equal 0. I solved by adding an x to both sides, so I have y is equal to x. So they're equal because if I took the value that I plugged in for y and then subtracted the value I plugged in for x, it gives me 0. When we were graphing equations, when we were using slope in our test prep class, and they had which point satisfies the equation? This point satisfies the equation because if I plug it in, does it give me a true statement? Does 2 minus 2 equal 0? Yes. Does 1 minus 1 equal 0? Yes.
So do you always, if you did like 3, 4, and 6, do you always have to do 0, 1, 2? Do you plug in different things?
You can plug in different things for x, whatever you want. I just pick values that are easy to work with.
Yeah, but wouldn't that make it off on the chart? Like different dots everywhere?
Not if you're plugging them in and doing the arithmetic correctly. They should all line up in a straight line if you're doing the arithmetic.
I get that they have to equal 0, but I don't get like how you can just randomly pick a number and it's
Remember the talk about an x being an independent variable? If you're independent of your parents, what can you do? You can do whatever you want. X can be whatever it wants to be. It doesn't matter what you plug in for x. We use easy numbers, so the arithmetic is easy. Plugging in 0 makes arithmetic a lot easier.
But do you have to do all that work? Can you just think of problems that equal 0 when you subtract them?
On this one, yeah, that's fine. On this one, you're going to have to actually work it out.
Okay.
Because the arithmetic would be a little more difficult.
So like if you got 2 for one of the answers, would you have to take 2 times 3 and 2 times 2 and then subtract it to where it equals 4? Like, for the x and the y?
Plugging them in. Oh, let's just see. If we took this value of 0, plugged it in. 3 times 0 is?
0.
Plus 2 times 2 is? 4. Does 0 plus 4 equal 4?
Yeah.
Yes. You can check yourself by doing that, but you don't need to. Once you get to here, because we're solving for y, so that it's equal to everything else, then you plug that in. That's going to be your value for x. You're telling the problem, okay, your values for x are going to be this, this, and this. And then you do the arithmetic to find y, because y depends on what x is. Moving on. Let's look at the problem on that lesson if you want. Watch this, Kelly, okay? Which one was it?
It's number 16. It has a fraction.
Okay. Well, that's already given to you. So on 16, you already have y is equal to something, so use a value for x that's a multiple of the denominator. So if you have 1/2, I would use 2, -2, 4, -4, 6, -6, something of that sort that'll reduce it down evenly. Does that make sense? Because when you plug in 2, that just makes it easy. You could leave it as a fraction, you're just going to have to, your graphing is going to be a little more difficult. Let's look at 17 real quick though. 3y plus 2x equals 3. We want to solve for y, Kelly. So we're going to subtract 2x from both sides. So 3y equals -2x plus 3. Then I'm going to divide by 3. So y is equal to -2/3 x plus 1. So then I'm plugging values in for x that'll make this arithmetic easy. If I plug in 0, 0 times whatever this is going to be 0. So that's always a good one to plug in. 0 times -2/3 is 0, plus 1 would be 1. Okay. Now, if your denominator is 3, let's use 3 and -3 to plug in. That way, the arithmetic will get easier here. So -2/3 times 3/1 plus 1. The 3 is reduced. I'd appreciate if you'd stay quiet. So this is 1. -2 times 1 is -2 plus 1, -1. So that's the value for y on that one. When we plug in 3, we get -1. And then if we plug in -3 plus 1, the 3's reduce. Now you have -2 times a -1 is a +2 plus 3. Sorry, plus 1 is 3.
What I don't get is like when you subtract the 2x and you subtract the 2x, so 3.
I'm not combining them. These are not like terms. So I put the x term first because this is slope-intercept form is what this is called. And in slope-intercept form, we put the term with the x in it first and then the number after. So I just rearranged those to get it in that form. Okay. Your assignment is 1 through 30. You have a test tomorrow. Good luck.